You know that feeling when you're staring at a document that's just way too long to read? Well, it turns out our most powerful AIs have the exact same problem. So what happens when an AI tries to swallow a massive code base or gets totally lost in a dense regulatory report? The results can be messy, they can be expensive, and the solution is actually pretty amazing.
So why is this even an issue? When you feed an AI tens of thousands of pages of text, or tokens as we call them, it basically gets its own version of too long didn't read. And the problem isn't just that it's a lot of information, it's about how the AI gets confused and the critical mistakes that can pop up when it does.
And these problems are very, very real. First up, cost. Asking an AI to read a novel's worth of text costs real money, and it adds up fast. Second, speed, or what we call latency. The more it has to read, the slower it gets, which is a huge pain for real-time applications. And maybe the most important one, accuracy. Models have this weird habit of paying attention to the beginning and the end of a document, but kind of forgetting what's in the middle. Researchers literally call this the lost-in-the-middle problem.
Now, this whole bottleneck thing is a headache if you're analyzing a long report, sure. But when you apply it to computer code, it becomes a potential catastrophe. The way code is built makes it uniquely vulnerable to all of these problems.
So this slide really gets to the heart of it. Natural language, the way you and I talk, it flows in a pretty straight line, right? One idea follows the next. Code, on the other hand, is a tangled web. It's full of these hidden connections where a function in one file depends on something in a totally different file 5 folders away. The meaning isn't on the surface, it's all in the structure.
And this quote from the source material just hits the nail on the head. These complex dependencies are exactly what trips up an AI. It can't just read code like a book. It has to understand it like a giant interconnected blueprint, and that's a massive challenge when the blueprint is the size of an encyclopedia.
And this is exactly why one of the go-to solutions for this stuff, called Retrieval-Augmented Generation, or RAG, just doesn't cut it here. You see, RAG is basically a super-powered search engine. It finds text that looks similar to your question. But in code, the most important piece of the puzzle might not share a single keyword with your query. RAG is looking for similar words when it should be looking for logical connections. It totally misses the point.
So, if the old way is broken, how do we fix it? Well, we need a much smarter way to squeeze all that information down, and that's where this new framework comes in. It's called LongCodeZip, and it's basically an intelligent compressor that knows exactly what's important and what's just noise. LongCodeZip has this really elegant two-step process. I love this analogy. Think of it like a triage doctor in a busy ER. First, in step 1, the coarse-grained part, it quickly scans the whole scene and identifies the most critical patients, right? The most important functions. Then, in step 2, the fine-grained part, it performs delicate surgery, line by line, cutting away everything that isn't absolutely vital.
Okay, that all sounds great in theory, but how on earth does it know what's vital? How does it make those smart decisions about what to keep and what to just throw away? Well, the secret sauce comes from a really cool concept in information theory.
It all starts with this idea called perplexity. And really, you can just think of perplexity as a measure of surprise. If an AI is reading something and the next word is totally predictable, its surprise or perplexity is super low. But if the next word comes out of left field and makes no sense, its perplexity score shoots through the roof. So LongCodeZip brilliantly uses this idea of surprise to figure out what's important. It calculates a relevance score called Approximated Mutual Information, or AMI. Here's all you need to know. A piece of code gets a high AMI score if adding it to the context makes the main task less surprising and more predictable for the AI. It's not looking for keywords, it's looking for the puzzle pieces that make the whole picture snap into focus. So once every chunk of code has its own relevance score, LongCodeZip faces this classic puzzle called the knapsack problem. Just imagine you're packing for a weekend trip with only a small backpack. You can't take everything, so you have to pack only the most valuable, useful items. That is exactly what LongCodeZip does. It packs its limited context backpack with only the highest scoring, most relevant pieces of code.
Okay, that theory is super cool, it's really elegant, but let's be honest, does it actually work in the real world? Let's take a look at the results.
The results are, well, they're kind of staggering. In their tests, the researchers hit a maximum compression ratio of 5.6x. Let that sink in. That means they took a massive amount of code and shrank it down to less than a fifth of its original size, keeping only the absolute essentials. And here is the absolute kicker. You'd think shrinking it that much would have to hurt performance, right? Nope.
It didn't sacrifice performance one bit. In fact, by cutting out all the irrelevant, distracting noise, LongCodeZip sometimes helped the AI perform even better. Turns out, less really can be more.
Let's put some hard numbers on that. Check out this table. A standard RAG method does okay. It gets a performance score of about 60 and compresses the data by about 3.7 times. Not too shabby. But then look at LongCodeZip. The performance score is higher at over 63, and the compression is way, way better at 5.6x. It's a total win-win. Better performance with way less data.
And this chart really tells the whole story. As you start squeezing the context more and more, removing information, look what happens. The other methods just fall off a cliff, their performance tanks. But LongCodeZip, it just hangs right in there, maintaining a super high score even when it's working with a tiny fraction of the original information. That is how you know it's keeping the right stuff.
So yeah, this is obviously a massive deal for software developers. But the so what here is so much bigger than just code. This is about fundamentally changing how AI can tackle enormous, complex information challenges.
Think about what this means. This kind of smart compression makes powerful AI cheaper to run and way faster. But the real magic is that it unlocks the ability to solve problems that were just off the table before. Imagine an AI that can sift through those thousands of pages of dense regulatory documents we mentioned and find the one critical compliance risk in seconds. That's the kind of potential this approach unlocks.
And that brings us to the biggest question of all. At the end of the day, code is just one type of complex, structured information. This whole principle of finding relevance by measuring surprise, that's a universal concept. So if we can teach an AI to find the signal in the noise of computer code, what's to stop us from doing the same for legal documents or medical research or financial filings? The question isn't just what new worlds we can unlock, but what massive problems we can finally solve.